Okay, we're going to talk about how we can add two of these vectors graphically. So let's say that we've got two vectors. Force 1 is 10 newtons, and it's going at an angle of 60 degrees above our x-axis, so we'd write it down like so. And then we've got another force acting on an object, 11 newtons, and it's going at a direction that's 70 degrees below our x. How do we add them together? What do you want, Dylan? Just to see?
I'm just going to pick up my...
There are two ways to do this. The other video starts talking about mathematical ways. We're going to do the graphical addition method here. So in order to do that, I'm going to grab these two and we're going to show it just a little bit different. The way we do this is called a head to tail method. And that means the head of the vector is the part with the arrow on it, and the tail is the part with the dot, usually a dot on it. And so I'm going to take my first vector down here, and I'm going to move it to my desk so I can do this a little more easily. I'm going to take my two vectors, I guess I can take them all together. Move them down here. I'm going to have to break these apart, so hopefully I can do this fairly easily. And I'm going to put the tail of my second one right to the head of my first one. And my resultant vector then goes from my original starting point down to, or over to, my end point. Now unfortunately, this shows, well, fortunately or unfortunately, this shows the weakness of this method. I did not measure those two vectors. You saw me just sketch them up. And so I didn't get scale measurements on them. The important thing here is that you must measure out the lengths of each vector. And you must measure out and accurately show the angles. And if you don't do those, like I didn't, it won't really turn out accurate at all. But if you're very careful with it, it will. So I don't really want to do any better than this. But let's just pretend that I did do better. The way that we then figure this out is to take a ruler, same scale, and we would measure these, and we would get a length. And from this scale, it looks like it will be something around 6 newtons. Then we get a protractor and we measure the angle relative to something else. Well, the way I've drawn it, it looks like it is straight to the right. So if it is in fact straight to the right, I don't really have to measure an angle. It would be 0 degrees above or below. I would just list the direction. This direction I'd list as x with a little hat above it, caret above it. It's called x hat. This kind of marking indicates that it is something right along the x direction. This is called a unit vector. It's got a length of 1, so multiplying your 6 newtons by this doesn't change how big this is, it just tells us what direction it is, that it's in the x direction. Now, as I said, I wasn't at all careful sketching these. If you're going to use a graphical method, you must be really careful. So you measure out the first one, use a protractor to measure 60 degrees, and then use a ruler to use whatever scale you've decided, 10 units out that way. And then you come up here and you say, okay, I'm going to start my new origin right there. I'm going to draw my second vector. And that was 70 degrees, so I take a protractor, move 70 degrees down, and then the ruler with the exact same scale, 11 units this way. So technically speaking, it probably should be down here, right? But once you've sketched that, and if you have multiples, it's okay. You go back to your first or your original origin of the very first one. Draw a line from it to the end of your last vector, and then use that to make measurements. So you measure the length and the angle from that. This is a really nice method. It's fairly quick But if you screw anything up, it makes a big, if you sketch it or if you don't measure right, it makes a big change. The other method is, and the more reliable I find, is the mathematical method. The mathematical method, I'm only going to highlight here on the video because it is in the part 1 of this video, and then in class we'll actually do it. But the mathematical method involves breaking each vector up into components, and we'll talk about what that means in a sec. And then we add up components that are in the same direction. So if we have multiple vectors with a component pointing to the right, we can add those up. And then we'll combine the 2 remaining vectors, and we'll see exactly what that means. Essentially what it means is that when we break them up, we're going to break them up into components that are left and right, and components that are up and down. We can add all the left and right components together. Separately, we add all the up and down components together. And then when we get finished, we have one vector that's to the left or right, one component that is to the up or down, and we can find out what our total is by combining those 2. So I'm going to stop the video right now because we did that in the other video, and then we'll take our example from up above and do this method with those vectors.